Uh, so is everyone back? Or do we have to wait for anyone? So we will start from where we left. We will go script by script. I will tell you how to write, how to read the scripts and how to write the script. एक तो मैंने बताया how to make use of readily available scripts. Take the portion, copy paste and make changes. Now we will see how to read the script. We will go example one by one and then we will try to see help options also. So I will start with the first one. Again, I will come back to the JavaScript basics. First script, uh, note on commenting the code. You can read this content. Uh, so commenting, basically, why do we want to comment? We want to comment any code because we want to prevent it from running. Suppose you have a big code, a big many lines of code. Suppose you want to test line by line without executing it fully. So you can comment portions of it, then it will not be considered by when you run it, right? You can it will ignore. Or there can be another purpose is to write a comment to describe the code, what any line does. It will help not only for others to understand your code, but also when you come back after some days, if you come back, you should be in a position to understand what you have done earlier. That is also, so it is a very good practice to write code wherever it is required. To write comment wherever it is required to have an proper understanding. So it improves code readability. You can prevent it from running. So if you want to comment any line, if I type anything here, it is in black, or it is, if it is any in color which is not green, that means it is non-commented. Now if I want to comment this line, you have to simply put two forward slashes at the beginning. The shortcut for doing this is you can select the whole line and then press control forward slash, control forward slash on your keyboard. There are two slashes, right? One is forward slash and one another is backward slash. So control forward slash. And this can be used for commenting as many lines as you want. You can select the entire portion and then you can click control forward slash. If you want to uncomment it, again you select the portion and press control forward slash. Otherwise, there is one way, like I have done it here. See, I have started with forward slash asterisk and ended with asterisk forward slash. So whatever you keep in between these two marks, it will be commented. So whatever this entire portion is commented. So I have used this provision to, what I have done is I have given it as a lecture, something like a lecture note. So the third purpose is I am instead of giving it in a separate document, I am including it as a lecture note, like you can read about commenting the code here. I hope it is clear. Now let us go to the script. First script. It is asking me whether I want to abandon my any changes, because this is my original means it, I am the owner of the script. So if I make any changes, they will again be reflected in your script also. The script will be changed in origin. You cannot change it, but I can change it. So I have to be a bit careful whenever I am working on my script. You please you can get any previous version of the script also in Athinjan. But that is not that important. But you can bear in mind that you have to be careful not to lose anything when you are working on your own script. But as long as it is provided by some other one, you need not worry because you won't be able to make change. So in any programming language, the first script that that we write is printing a statement, printing hello world in any language. So here it is JavaScript. You can see the line is this one, print within parenthesis. We have to put your string. I hope you understand the basic data types in any programming language. Here in JavaScript, here it is either it has to be a number, then string, then boolean. What else? These are the basic data types. When we are talking of data structures, like for example, you can store, basically you want to define a variable and store some value in that variable. Suppose you are storing x is equal to 5, 5 value in x and 7 value in y. Variable x is equal to 5, variable y is equal to 7. And if you define print x plus y, then it will print the value 12. If you write a statement print x, it will print the value of x, or print y value of y. So this print is an inbuilt function. These number, boolean, this string, these are all basic data types. Data types, they can be used for storing single value. Suppose you want to store multiple values. For example, you are collecting some Landsat or Sentinel data is being collected from different dates. So the values will change over time. Any value, band reflection value in any band, or NDVI value, anything, it changes over a period of time. Right? If you want to store such multiple values, you have to use the data structures, something like list. Have you heard of list? Dictionary? Have you heard of these things? So I will teach only what is required. I will not teach more than you are not here for learning the programming language. So lists and dictionaries are two data structures which are used for storing multiple values. Okay, I will come to that. Actually, our next script is JavaScript. You can see number 3, number 4 is on strings, number 5 is on numbers, number 6 is on lists, number 7 is on dictionary. I am covering everything and then I will run them. So suppose it's like multiple values I am saying. So lists, always we use square brackets, and within square brackets you put comma separated values. The values can be numbers, the values can be strings, the values can be booleans also. For example, rainfall values from different rain gauges. It can be list of values. If it is names of the rain gauges, it is list of strings. Okay. So in lists, position is very important. Lists, suppose the first element is 1. Suppose there is a list containing numbers 1, 2, 3, 4, 5 within square brackets. So the first element is 1. Its index is 0. Indexing starts from 0. Please remember, in lists, indexing starts from 0. Second element's index is 1. Third element index is 2, and so on. Okay. If there are n elements, the index of last element is n minus 1. So in lists, we have indexing starting from 0, and position is very important. Whereas in dictionary, instead of square brackets, we use curly or flower brackets, and there you want to be have more flexibility. You don't want to be constrained by the index. There we can have key value pairs. Key value pairs. For example, you are storing information about one rain gauge. So what are the different variables that can be? Location of the rain gauge, longitude, latitude, value of rainfall, and so on. So for every key, like latitude can be a key, longitude can be a key, location is anyway, we have got longitude and value of the rainfall can be a key. You can write it fully, value of rainfall, longitude, latitude, and then colon, you have to put the value. So here position is not important. You can define latitude before, longitude before. You can define value of rainfall before or after. It doesn't matter, because when you want to get the value of rainfall or value of the longitude or value of the latitude, you can call the key, and associated with the key you can get the value. You can get the if longitude value or latitude value, or the person in charge, say it can be the person in charge will be a string, name of the person will be a string, you can get the value of string. So in dictionary you can have this key value pairs. The position is not important, whereas in lists position is important, where values are saved as per index in a sequence. So if you are making any changes to the list, you have to be careful. And if it is dictionary, it will be very easy to save the properties. जैसे हमने वेक्टर डेटा, for vector data you have lot many attributes. You can store all such properties as a dictionary for any vector data. Even for an image, all metadata for a raster image. What is metadata? Data about data. Like when was the imagery collected? What was the date of collection? Then which sensor, which mode, etc. So many things can be there. What was the cloudy percentage on that day? All those are properties. You can save them in as a dictionary value, key value pairs. So you have to learn only this much of JavaScript. You don't require anything else. Okay? You have to bear in mind lists, dictionaries, and these scripts will explain what are strings, some important functions that are associated with strings, numbers, etc. I am leaving this part. It is for you to practice, and I have also given you how JavaScript introduction. If you go to the documentation, you will find JavaScript introduction to JavaScript for Earth Engine. There is some material, you can go through it, but it is not much essential to know. If you are aware of list, dictionary, and how to get any value from it, how to get any value from a list, you have to pass its index. How to get any value from a dictionary, you have to pass key, then you will get the value, right? So if you know how to get any value, how to store, etc., it is sufficient. JavaScript, not much is not required. So I am skipping this JavaScript basic parts, and because this objects and methods, I want to skip it. I don't want to confuse you at this moment, because it will be too much for you to grasp. It is actually something related to object oriented programming language versus functional programming language. If you are much into programming, then you can understand these things, but otherwise you forget about it. You can go through the notes afterwards, like you can read the scripts, but for the time being you can forget. What is essential is, in simple JavaScript, if you want to add two numbers, variable x is 5 and variable y is 7, then if you want to add simple addition, you can simply do x plus y. Whereas in Earth Engine, that is at the client side itself, you can do at your end itself. But suppose you want to multiply every value of a pixel with a constant number. Suppose there is an expression 2 into NIR plus 3 into SWIR, something like that. Some expression is there, some index, instead of normalized difference index. Suppose there is an expression for calculating some index which will may take every pixel. This is red band, green band, blue band, NIR band, SWIR band, etc. So every pixel, corresponding pixel will have one value. Then 3 into NIR plus 2 into SWIR1, etc. Some expression is there. Then you have to take that value from each band and you have to do calculate that pixel wise. You have to do the evaluate the expression and you will get a new image with the evaluated expression, right? Corresponding pixel values. So yeah, in such cases, what I was talking about. So suppose if you want to multiply, when you are doing this 2 into pixel, all pixels, then you cannot simply use 2. You have to put it in a container ee.number 2. Otherwise, the server will not understand it as a number. What is a simple number is not understood by server. You remember that. So whenever you want to call any image, you have to put it inside a container ee.image within brackets, parenthesis, and then the ID of that image. Whenever you want to fetch any image collection, you have to put it in a container ee.image collection. Similarly for numbers, for strings, etc. Please remember this. Okay. So whenever you, because all the computations are happening on the server, there are few things that you can do at your end without sending the command to the server, like simple additions, etc., where you don't require any, you don't require to send the command to the server side. Then you don't require those containers. Okay, so don't get confused. Whenever you see e.number, e.string, and then within string brackets there will be, that is a way of communicating with the server. Okay, so that much part I think it is enough. Let us move directly to third. Also I am skipping 1, 2 and 3. I am skipping. I will come to remote sensing basics, because you had remote sensing session and we also have been seeing how to we will do it from basics, like how to fetch any data, how to work with single band, how to work with multiple bands, etc., multiple band imagery, etc. So here also I will be selectively picking some scripts and then I will run and you can do that. You can follow me. So here also overview of images and image collections. You can see the description part is given. This will be available with you also afterwards. Also you can go through the description, etc. So images, I have told you, images are nothing but raster data model. Images are image is equivalent to raster. Image collection is equivalent to raster collection stack of images. Feature is equivalent to vector. Geometry, feature is nothing but geometry plus some attributes. Okay, so how to create a constant image, how to create any image stack, etc. These are introduced here. I am not going to through it. How to search and load an image. Now this, let us see. The script number 20, search and load an image. Now we will, this is an exercise. You will also do along with me. What we will do is, we will search for one popular digital elevation model, SRTM. Either you can go to data catalog, search for the data set and then bring it into your script, or you can search for the data set in the search box here. On the top you see search for places as well as data sets. Here we will search for the SRTM, DEM and we will display it for our area of interest. Okay, simple task. Okay, let us start with a clear window. You can, as I said, you can open as many tabs as you want. So everyone please open a new tab, code.earthengine.google.com. Okay, everyone open this code.earthengine.google.com, a new tab. Now go to the search box and then press SRTM. When you press this SRTM, you will get so many results. You can see SRTM digital elevation data version 4. Now what are these versions? What is SRTM? Does anyone know what is SRTM? It was a mission scheduled. A mission was flown in 2000 and it revolved the earth and it collected information, elevation information, and they generated a digital elevation model. How a digital elevation model is generated? Digital elevation model is nothing but a grid where each pixel contains the elevation. You can assume it, you can see it as an average elevation of that pixel. Suppose if the cell size is 30 by 30 meters, so it is building, entire building may come within 30 by 30 meters pixel. So but this is something which is constructed over the there are time is not enough to explain. There are things like distant terrain model, DSM, DTM and DEM. DEM is what we generally get because generally acquired imagery, it also captures the height of the man-made and vegetated surface also. So whatever elevation you are getting is a generated, DEM is a generated data set. It can be derived by many ways. One way is you have the field data, you go by field survey, you collect the data, elevation of the different points and you generate a raster data using interpolation technique. Another way is you stereotype images. How you get an estimate or how can you visualize or how can you make sense of depth, because you have two lines of vision from your eyes, right? Similarly, when a satellite is orbiting the earth, from this position it captures some location on the earth and from this position it captures again. There will be some overlap between these two locations. So when these two images are, these are known as stereo phase, these are used for getting elevation information. Okay, so this is something generated. It is not actually captured. It is generated data set. So first version, and at the time of generation, there will be many errors inside. Like there may be cloud cover, cloud shadows, hill shadows, many things. So maybe there may be many acquisition errors. So they keep on improving it. Now tomorrow or day after tomorrow, I guess you will be having a session on basin delineation. So there what you will do, you take a DEM and then first you fill the sinks. So you are trying to fill all the abnormal values. Otherwise what happens, if there is an abnormal negative value, all water will artificially flow inside that pixel. Right? There will be no flow at the outlet. So you have to hydroprocess your DEM to remove all such sinks and also spikes. Some spikes may be there. These are due to acquisition errors. So that is known as hydroprocessing. That is the first step. Okay. So they keep on improving and you have better versions, version 1, version 2, so on. So this is version 4, SRTM digital elevation. It is at a normal SRTM original data was at 30-meter resolution. This is field sinks. This is version 4. I think it is at 90-meter resolution. Each pixel size is 90 by 90 meter. So whenever you are typing, you will get all the different data sets. You see, these are all the rasters. Now I will select this. Now if I take my mouse onto SRTM, what you can see, an import button is there. That means you can directly import it into your script, right? Or let me do import. Once I click on import, what has happened? On in my script, a new variable is created on the top. By default, its name is image. If it is an image collection, its name will be image collection. Otherwise, feature or feature collection. You have to change this variable name. Variable name is SRTM, which is an image. Okay. If you directly import it, if you don't want to import it also, then also you can, what you can do is you click on the data set. Please pay attention on the screen. You click on the data set, then the data set page will open. This I have shown it in the data catalog. Same thing. Now there will be description, what it is, shuttle radar topography mission, which was originally flown I think in the year 2000. You can see dataset provider. Now this is the ID. So this is a single image. This is the ID, and you can also see the number of bands is only one band. This is not electromagnetic band. There is only one value, elevation value. It is one band, and minimum value, maximum value, resolution, as you can see, 90 meters, etc. Now, important thing is this collection snippet. You can copy this. Copy, you see this square button. If you click on this, that will be copied. This one. You can also import from here. What you have done earlier, that you can also do it from here. Otherwise, you copy it, and then what you can do is inside your script, you can define a new variable. Now, whatever is in green is commented. Whatever is in bold, whatever is in bold, black and bold, that is keyword. VAR is variable keyword. Whenever you want to define a new variable in JavaScript, you have to use the keyword VAR. Then put any variable name, X or Y or Z. But generally what we want to do is we want to give a name which is understandable. So here I can give a variable name as SRTM. Variable SRTM equal to, and then paste whatever you have copied there, collection snippet. And then every line every line in JavaScript ends with a semicolon. So here either you go from imports, or whether you define it in separately as a separate line. This is line number 1. Import section is on the top. That is no longer required because I don't want to do the import. I want to type it directly. So I will delete it. So you can see delete button will come next to it. You will see the recycling bin. So this is here in the first line. What I have done? Simple. Variable, name of variable is SRTM is equal to, and that collection snippet ee.image, that is container, inside within single quotation or double quotation you have to give the ID which is unique. Okay. So this is, I have assigned one variable and named it as SRTM. This is SRTM. Suppose I want to display it. Suppose I want to display it. For that, there is a function map.addLayer. Function is simple, map.addLayer. Now, this is case sensitive. You may make a mistake. What you can do? I have told you there is documentation. Where is documentation available? Under docs. Under docs, you should see map. Under map section, there are many functions. You can see map.add_layer. You can see map.center_object. You can see map.getScale, map.zoom, getZoom, etc. Right? What I need is map.add_layer. If I click on this function, it gives me description of that function. What is that function? Map.add_layer. How many parameters it takes? 1, 2, 3, 4, 5. object, visualization parameters, name, shown, opacity. These are the 5 different parameters. And it does something. What it does? It returns a new map layer. What it does is it simply displays your Earth Engine object. Earth Engine object can be a image object. Earth Engine object can be a image collection object. It can be a feature object or feature collection object. So whatever you want to display, that is compulsory parameter. सुनिए यहाँ पे 5 पैरामीटर है ना, बट आपको इफ यू सी सेकेंड, थर्ड, फोर्थ, फिफ्थ पैरामीटर इज इटैलिसाइज्ड. इटैलिसाइज्ड का मतलब है दीज आर ओनली ऑप्शनल. If you don't provide any value to those parameters, by default whatever is defined within it will take. But compulsory parameter is E object, which is nothing but Earth Engine object. Earth Engine image object are. Now what is my Earth Engine image object? Here in my case SRTM. So if I put map.add_layer, I have to, within the brackets, I can simply pass SRTM and then press enter, run, then it will run. Now, again, I don't want to write my code. Please pay attention. Simple, very basic thing, but it will be very useful. I don't want to write my code. I can copy it. Otherwise, what I know is it starts with map, then put dot, then press control space. Then it will show me all the functions which are under map. Now I can select map.add_layer. Okay. Now you have noticed something. Whenever you are typing a function, it will be in purple or violet. Comment is green. Black is usual code. Black bold is keywords. Purple unbold is function. Whereas container like ee.image is purple bold. So these are different color conventions. Using that you can get some idea. So now map.add_layer, how many parameters it takes? It takes 5 parameters, but for now what I can do is I can take only one parameter, first parameter, that is SRTM. E object ka value SRTM. E object is the name of the parameter, whereas value of the parameter is also known as argument. Argument is SRTM. And then end my this with semicolon and then run. So you can see something is being done in the map window. What has happened? You can see a new layer is added. By default it has taken a name layer 1. And something has been added, and you can, just like in GIS software, you can check and uncheck to keep it active or inactive. But can you make any sense out of it? Can you get any information, visualization? You can't get, right? Why? Huh? Please speak loud. Huh? Print is just to see the metadata. यहाँ पे when I am visualizing, मेरा question, are you able to get my question? When I am trying to add SRTM layer on my screen, now it has been displayed as a layer 1. You can see this, but I cannot make any sense out of it. I can definitely get values of each pixel. How do I get the value of any pixel? Go to inspector and click anywhere. You will get the coordinates, longitude and latitude as well as elevation. Elevation is 1663. Each pixel size is 30 by 30 meter. Sorry, 90 by 90 meter in this case. But I cannot make any sense out of it, any visualization. Visually, I cannot say which area is higher of higher elevation, which elevation is of lower elevation, which pixel is of lower elevation. So if I want, because what has happened, you are seeing a small portion of the earth, whereas the values are stretched between the minimum and maximum values of the whole world. Understood? So here the stretching is done between some whole range of the values for some part of the earth. If I want to change it, what I can do? You see this settings button? सब लोग follow हो रहे हैं ना? I will try to go slow. Okay, if I click on this settings, you can see the range is minus 327672 plus 32767. Because the type of the object, the type close. Let me close this. Let me print this. If I print SRTM, what will happen? All the metadata, all the information related to this SRTM dataset will be printed onto the console. Just to check. So if I run this, not save. If I run this, again it is being displayed, and then in the console, what is displayed? An image is displayed. How many bands are there? Only one band. And you can see the integer of type signed integer 16. Signed integer 16. How much is 2 power 16? No, 16. I think it will be around minus 32767. So it is signed integer. It takes both negative and positive values. The range is very big, whereas the actual values are small. That's why everything is appearing in one color here. There is not much change, even though there is some bright spots are there, but you cannot see it. So if I want to change this visualization, what I can do again, I will go to this layer. I will click on this settings. And I will, instead of stretching for the whole range, I can do the custom stretch. Maybe stretch between one standard deviation values are 98 percentile, maybe 98 percentile. I will stretch it. Therefore, you see the range has automatically changed. The range is between 18 meters to 3705 meters. And then I will click on apply. Now you can see something. It is grayscale. Black values are of low elevation. Higher values, bright values are of high elevation. Right. So these are, I think, Rocky Mountains, higher elevation. There are valleys in between. Right. आपने कुछ गलत किया होगा ना? आपने some mistake you must have made. Where और SRTM के बीच में आप वेरिएबल एक ही लाइन में डिफाइन करना है ना आपको. देखिए, आप कैपिटल लेटर को स्मॉल लेटर करने से या स्मॉल लेटर, दिस इज केस सेंसिटिव. Even if you make any mistake, that's why the entire purpose of me telling you how to get auto completion. Why did I tell you about auto completion? एक बात मेरे बात सुन लीजिए, आप आपस में बात मत करिए. Why did I tell you about auto completion? Control space. So that by typing आप L के लेयर का L को अगर आप स्मॉल लेटर करेंगे या वेरिएबल में V को कैपिटल करेंगे, then it will give you some error. इसीलिए it is case sensitive. You cannot type anything because it has to be understood by the server, right? तो इसीलिए आप ध्यान रखिएगा, वो ऑटो सजेशन वो सब देख लीजिए, कॉपी पेस्ट करिए या ऑटो सजेशन यूज करिए ताकि ऑटो कंप्लीशन, सॉरी, so that nothing will go wrong. Simple syntax mistakes will not be there. So is it clear? अभी मान लीजिए ये यूएस को दिखा रहा है. अभी suppose you want to center it at Assam Guwahati, what you need to do? If I want to center at Assam Guwahati, what I need to do? There is one function map dot. So if I don't want this print statement here now, I can, what I can do, I can comment it, control/. Now here again I will type, please pay attention. अगर आप मिस होंगे तो I will not repeat. We only have 2 more hours or 3 more, 2 hours only. Please pay attention and get as much as you can. Afterwards you will not be able to do on your own. So you see, again I am doing it. Please pay attention on the screen. अभी मुझे एक function I know, map.setCenter. Either you can search in the docs, map.setCenter, map.setCenter. Okay, so this function you see, map m capital map dot set c capital. So you have to stick to that definition of the function. What it takes is, it takes longitude, it takes latitude, and it takes zoom level. Again, zoom is italicized, which is an optional parameter. If you don't define zoom also, it will take some zoom value which is internally defined and it will display. But you have to compulsorily pass longitude and latitude, right? Compulsorily you have to pass x and y, then only you can center it at any portion. So you know this function is there. Now again, not to make any mistake, I will make use of auto completion. So I will type m capital AP dot control space. Then you look for map dot set center. There are 3 variables, right? First variable is longitude, second variable is latitude, third variable is zoom level. Now tell me coordinates of Assam, or what you can do, you can search for Guwahati here. Assam, then the map will go there. I can uncheck this. I will, okay, I will use inspector tab, click somewhere here, and I got these coordinates. So map.setCenter, I can copy these coordinates, which are 91.7427, comma 26.1612. Zoom level varies from 0 to 24. By default it will take, I think, median value, but I am not much bothered. So let me give these 2 compulsory parameters. Now if I run this, So at Guwahati, centered at that some particular zoom level, you have the SRTM DEM displayed. But because it is mostly, I think, valley, there is not much change in the elevation except for hills. But still, if I want to get proper visualization, I will do again. I will go to settings. I will go to custom. Again, stretch 98 percentile. That means first 2 percentile and last 2 percentage lowest values and 2% highest values, which may be outliers, may be removed. Okay. So, and then apply. Now you can see some in the southern bank of Brahmaputra, you have hills, and after this valley, northern Assam near Arunachal Pradesh, we have high elevation. These are the valleys. You can check the values also. These values are pretty high, starting from 1100. Here, black portion is a plain area where elevations are around 40-50 meters, whereas here it is 1500 and so on. If I go much uh, in the northern direction, I will get still higher values, 5000 meters, 6000 meters, and so on. Right? You can see it here. Okay. So you know how to search for data, how to import it, how to define using code snippet, right? अब एक बात देख लीजिए. When I was searching for SRTM, here, apart from the description, bands, etc., you also have one C example. अगर आप डेटा कैटलॉग में भी जाएंगे, मैंने बिफोर लंच मैंने आई हैव shown that. So if I click on this C example, a new window will open, new tab will open. It will give you an example of using this data set. For every data set, you will get this example. Some are other example. If I click on this C example, a new tab is opening. code.earthengine.google.com, one new tab, and this is a simple example. The same thing, instead of SRTM, he has given the name dataset, and then he has selected band elevation. Here there is only one band, there is no need for selection of any band, but still, suppose if there are multiple bands of Sentinel-2 or Landsat multispectral imagery, you can select red band, green band, and blue band, and choose only 3 bands and then generate a true color composite or false color composite. ये कल आपको बताया गया था true color, false color, है ना? बताया ना? That you can do. False color में अगर NIR को आप red देंगे, you can easily identify vegetation, bright red in color, right? So, and then there is one function e.terrain.slope. So whenever you find any function, you always make it a habit to look into the documentation. You copy this function e.terrain.slope. ये मैं example का बात कर रहा हूँ, and go to docs, and then you search for this function e.terrain.slope. So you see this e.terrain.slope. Click on that function. What it does is it calculates this function takes an input which is an DEM to calculate slope in degrees. For every pixel, it will calculate slope. From elevation, it calculates slope. So you can easily generate a slope map if you have DEM map, DEM image, right? Using this function e.terrain.slope. And what it returns? It returns an image. That means it gets me another raster image using elevation dataset. So here it is taking elevation as an input, and it is calculating slope at every point. And then in this line, what I am doing, I am centering my image to particular location, longitude and latitude, and then I am adding my slope. The slope layer which is generated, I am adding, and these are visualization parameters, that is the second parameter. Third parameter, that is slope, I am giving a name. If I don't give any name, it will be like layer 1, layer 2, by default it will generate. So if I run this, you just observe what it does. It is a slope map of Grand Canyon. You know Grand Canyon? There is a valley in which Colorado River flows, and on both sides there are almost vertical cliffs. So if I zoom in, you can even see the map map on, and you see in between the river is there, where you can check the value using inspector, the way the slope is very less. However, on both sides, the bright portion, the slopes are very high. They are as high as 50-60 degrees, almost something like this, almost vertical cliffs, right? अभी आप एक काम करिएगा, डू इट। आप ये एग्जांपल लेके फॉर Assam, this plain area slope doesn't vary much, but if you go to hill areas, hill regions, you make changes in this script. This script is from SRTM version 4 example script. You make changes in this script to visualize slope map of the whole northeast. ठीक है, एक करके देखिएगा। अगर जूम ऑप्शन, इसको आपको जूम ऑप्शन भी चेंज करिए ताकि पूरा नॉर्थ ईस्ट दिखेगा। आपको कहाँ पे चेंज करना है? ओनली लाइन नंबर 4 यू हैव टू चेंज। ओनली लाइन नंबर 4 you have to change longitude, latitude and zoom level, so that the entire northeast looks in your map window, and you will see the slope map of entire northeast. ये ट्राई करके देखिएगा, वेरी सिंपल एक्सरसाइज। स्लोप वाला आप इसमें यहाँ पे एग्जाम्पल बताओ। मैं बता रहा था, यहाँ पे एग्जाम्पल है ना, एक नया स्क्रिप्ट है ये, इसको रन करो, इसमें स्लोप जनरेट, ये यूएस में आपको ग्रैंड कैनियन दिखा है। अब इसमें आपको लाइन नंबर 4 चेंज करिए ताकि नॉर्थ ईस्ट पूरा दिखेगा, स्लोप मैप दिखेगा। The input is same SRTM and you will generate the whole slope chart. Change the zoom level and see at what level you will get the whole northeast. You change the longitude, you change the latitude, and then zoom level so that you see the entire northeast. वो ट्राई करके देखिए ना, डिफरेंट देखिए, डिफरेंट वैल्यूज ऑफ जूम लेवल आप करके देखिएगा। जूम लेवल वैरीज फ्रॉम 0 to 24। हाँ दिखेगा, क्योंकि वो डिफाइंड है 0 to 24। आप गौहती का ही आप लॉन्गिट्यूड लैटिट्यूड ले सकते हैं, एंड देन यू चेंज द जूम लेवल। जूम लेवल, आई एम रिपीटिंग, इट वेरीज फ्रॉम 0 to 24। टेक इट अप्रोप्रिएट, value. Take appropriate value. Mhm. First one will always be longitude because in X direction longitude changes.
Longitude means north south. No?
Huh?
Longitude means north south. No?
Longitude is हाँ vertical. क्या बता रहे? वो इसलिए हो रहा है कि आपका मैक्सिमम वैल्यू 60, तो वो रेंज ना, इट इज शोइंग द रेंज, आपको थोड़ा कम करना पड़ेगा. ग्रैंड कैंयन हैज हाई, देखिए प्लीज पे अटेंशन हियर. अभी मैं करके देख लेट अस डू दिस फ्रॉम हियर. You know where from where this script has come from. Example, I haven't made any changes. Now the first line, what it does, I am defining a variable data set. I am naming it as data set. Instead of importing, I have used it in a container ee.image, and within parenthesis I gave the id. Where do you get this? Directly in SRTM. If you search for SRTM, you can do one import. I am not doing import, but I am going here and copying this id, and then I am pasting it here and assigning variable data set. Okay, first line. In the second line, I am selecting. If I again I am repeating, select is a function. Now whenever you see anything in purple, it is a function. You can check the documentation, and this function is being applied on what? On a data set. What is data set? It is an image. देखिए, whenever you want to apply any function, you will observe this dot notation. If I want to apply a function on an image dot, then that function. So select is a function. You see, if I want to check in the docs, it is there under many things, but I want to see it under ee.image. Right, ee.image, because it is something which is being applied on an image. So if you see this ee.image, select, it select bands from an image. In this image, how many bands are there? Only one band is there. Elevation. How, where it is defined? It is defined in this description of the SRTM bands. Right? So I am selecting the elevation. So now my variable is elevation, which is a single image where every pixel has elevation value. Even SRTM data set has the same thing. Value is same because there is only one band. Suppose if there are multiple bands, it will be, select will be useful. Okay. Now the next one is, I am calculating slope using this inbuilt function e.terrain.slope. Again, if I see the documentation, e.terrain.slope, it calculates slope from a DEM. It takes a DEM and then it calculates slope at every point in degrees. So input I will pass as elevation e.terrain, and I am saving it under in a variable name slope. Now what is this slope again? Again an image. Every pixel will have value of slope. Now I am setting my map.setCenter. It is again a function. Again, if you want to check, copy docs, paste map.setCenter. It centers the map view at a given coordinate with the given zoom level. And as I said, long and latitude are These are not optional, these are compulsory, whereas zoom is optional. Zoom level varies from 0 to 24. I think by default it's optional. If you don't give any value, I think it will take 12 or so. So I can here I am giving the Grand Canyon some longitude, latitude and zoom level. And next what I am doing, I am displaying my slope image. So when last time when I added SRTM, I only used map.add layer, and within brackets I only give SRTM. Now here, in addition to slope, I am giving the second and third parameter also. Now if you check this documentation, map.add layer, there are 5 parameters, right? Map.add layer, there are 5 parameters. First parameter is compulsory parameter. The image or feature or whatever it is, you can see image or feature or which you want to add to the map. This is compulsory. Second parameter is what? Visualization parameters. Now you remember in SRTM, I have gone to the settings and changed the stretch to 98 percentile to make it visible. I have defined the visualization parameters indirectly, but here you can define it. Visualization parameters, remember, always it will be a dictionary where you can define minimum value and maximum value. What it means is the values which are 0 and below will be black, totally black. The values which are 60 and above, it will be degrees, it will not go much more than 90. It will be, they will be totally white. And in between, different gray levels, depending on the value, it will be displayed in different gray levels. As you can see, total white, then somewhat gray, black, etc. is there, right? So it is stretched between these two values. And third parameter is, what is the third parameter? Map.add layer. Name. Name, which is also optional. If you don't give a name to the layer, it will be displayed as layer 1 or layer 2 or layer 3 as per the sequence, how many layers you are displaying. Now, if I am giving the name, you can check this layer name is what? Slope. If I don't give it also, nothing will happen, but it will be named layer 1. And fourth and fifth parameter, I am not giving anything. Shown opacity. These are simple. If I want to show now Boolean, what is Boolean? Boolean, just like it is a data type, number, string, etc. Boolean can be take only two values, true or false. So suppose you want it to be calculated, unnecessary confusing होगा, इसीलिए मैं सारे options नहीं बताना चाह रहा था. There are options नहीं बताना चाह रहा था. It doesn't value any value. But if I run this, now what is happening? The value is generated, the layer is generated, but it is not shown. True means shown, false means it is not shown. Why is this useful? You don't want to consume your resources. You don't want to consume your resources to display. You can only want, you may when you zoom to the selected extent and then you can click on this. Otherwise it will calculate slope for the entire extent and it will show. It will take some time, right? And last one, what is the last option? These are parameters, as again I am saying, opacity. Again, opacity means what? You can even give 50% transparency and you can see the base. Like suppose if I give the value of 0.5, it value lies between 0 to 1. If I give the value of 0.5 and if I run this, and I will make it true only. If I run this, here I am giving all the 5 parameters. Now see what happens. So you see, it is 50% transparent. You can see the labels in the background, right? It is useful. Sometimes it is useful to check what is in the background. So opacity is 50%. If I make the opacity 0%, what will happen? 0% opaque means fully transparent, right? So nothing will come. It is fully transparent. It is active only. If I make the opacity 1, fully opaque. Understood? But those parameters are not much valuable, right? Show on opacity. What are more valuable is compulsory parameters, slope, and visualization parameters and name of the layer. If you define, because these are optional, I can skip it. Now I want to do it for Guwahati, for whole northeast. How do I do it? First I need coordinates of Guwahati. I can search for Guwahati, go to the location. I can uncheck this. Let me take some coordinate in Brahmaputra. 91.7207. Now I have to change this longitude. X is always longitude. 91.7207 and then 26.1842. Suppose if I run this. So at zoom level 10, it is giving me something. Now what is the problem here? The problem here is much of the now let me for whole northeast say I will decrease my zoom level. I will run. Still maybe I will make it 7. Run. Now why it is not much very much dramatic like Grand Canyon. Definitely it is not high steep cliffs are not there, but still what is the problem here? The problem here is with visualization parameters. These visualization parameters are for Grand Canyon. Whereas here the slope may be, how much do you think the slope varies here? 0 to maybe 30-40, not much more than that. In Himalayas maybe it may go up to 30-40. So if you want to check it, you can even check. Where you can check? Go to this settings. You do the stretching 98 percentage. You see slope is varying from 0.2 to 12.9. So 98 percentile values are 98% values are these between these two. Percentile means what? Only 2% only 2% values are above 12.97. Only 2% values are below 0.26. So I can change it to 0 to say 13. I can simply change it to 0 to 13 say 15. And if I run this, you will get better visualization. You can now get a sense of which are the high slope areas. As expected, the Brahmaputra Valley has level, not much change in the slope. You have Meghalaya Plateau, medium slope, and then these eastern hills and Himalayas, high slope. High is not as high as Grand Canyon, but relatively it is high. You can even check the inspector tab and click anywhere and get the slope values. It doesn't vary much. It is about 22, maybe 30 in Himalayas. And if in the plain Assam Valley, it is only just 0.05. You see, low values are as low as 0.05 because it is plain. Right? It is clear? Very basic. So this is how you can read the code line by line, make modifications as required, and then you generate. This is just visualization. We haven't done any kind of analysis. Suppose you want to calculate average slope of Assam. How do you do that? first you have to define your area of interest Assam, which is not easily possible using these geometry tools. It is not a rectangular square or a polygon, simple polygon. You have to go for actual shapefile of Assam. You have to input your actual shapefile by uploading the shapefile of Assam. And then there are functions in Google Earth Engine where you can, like, slope image is generated. Now for particular area you want to calculate the aerial average of that slope. There are inbuilt functions, reduce functions they are known as, which can be used for calculation of the average slope of that any particular area. Okay, we will do that. Let us move forward. ठीक है ना? Now let us go back to our script. कोई डाउट है किसी को? So this is how you search, and if I print anything, I get all the metadata. Print, map.add layer, these are all useful for checking our data. Now let us come to some useful scripts. Average elevation calculation. When is the tea break? 4 o'clock. So in 6 minutes, let us see the script, one script, and then we will break for tea. Go to script number 28, average elevation calculation. Average elevation calculation. Under 5, working with single band raster data, there is one script, average elevation calculation. अभी आपको कुछ नहीं करना है. You just run and see the result. And then let us try to make sense out of what is there in the script. And then if you can, please adapt the script, adopt it for some other area. Now this script calculates average elevation of a region of interest. Here my region of interest is what? Pune district. How? Now Pune district, I have uploaded my shapefile as my asset, and I have given public access to whosoever has this. Now if you see in the import section, there are two variables. In the import section, there are two variables. First variable is SRTM, which is the TEM, which we have been seeing, and the second variable is what? ROI, region of interest, which is the shapefile of Pune district. You can do the same thing by uploading your shapefile as an asset. We will do that. So these are the two variables. Okay. Either you can define in the import section or you can define in the script itself. Then in line number 11, what is happening? We are centering our map. Instead of set center, there is another function, center object. We are centering our map on our ROI at some zoom level. Okay, zoom level 8. Then we are adding our ROI. What is our ROI? Pune. Now let us run these two lines. I will keep these lines. What I can do, I can comment this. Only I will run this line and this line. Now if I run this, क्या हुआ? आपको दो लाइन एग्जीक्यूट हुआ है. एक फर्स्ट लाइन क्या हुआ? मैप डॉट सेंटर ऑब्जेक्ट ROI zoom level 8 and map dot add layer ROI and some color. These are visualization parameter. Color you can write it as hexadecimal number, or you can give simple color, red, blue, or etc. And then Pune district. Pune district is what? Third parameter is what? Name of the layer. You can see the name of the layer, Pune district. ठीक है. अब अगला next part of the script, what we are trying to do, we are calculating average elevation of using SRTM DEM. If I run this script, forget about what is happening inside the script. If I run the script, it will displaying some value in the console. It is printing my SRTM DEM metadata, and then it is displaying my value. Average elevation value is 651.931, so on. This is the average elevation value for Pune district. So inside, if you check the script, you see there is one function, average elevation, variable average elevation. I am taking my SRTM and I am applying this reducer, e.reducer.mean. You can get a sense of something, right? E.reducer, I am mean means what? I am averaging, and I am averaging over my ROI, which is Pune, and and I am applying it on what? SRTM. So you can read the script, right? You need not know that syntax exactly, but at least you can make sense out of it. And if you want to check what this reduce region does, you please check in the docs. Go to docs, paste reduce region. So it is being applied on an image SRTM. So reduce region. So it apply a reducer to all pixels in a specified region, in a specific region. That is our ROI. So either the reducer must have the same number of inputs, etc., etc. So what it returns? It returns a dictionary. You can also see it returns a dictionary. It is returning a dictionary with key value elevation, key elevation and value 651. Right? Now we will break for tea. But what we need to do is, I want all of you, if you have any access to any shapefile, Assam, state or Assam, any state, district of Assam, do you have readily available shapefile? We will do an exercise of how to create an asset, how to upload a shapefile, and then instead of Pune district, we calculate average elevation for that particular district. Do you have any? Yeah. If you don't have, then I will create one and I will circulate. Then you have to upload it. किसी के पास है तो we will make use of it. Otherwise, I will create. Okay, then we will break. अच्छा what we can do is, let me know. Let me I think I will show one source where you can get shape files. Online Map Survey of India. Okay, you have to have your own registration to access freely available shapefiles on this website, onlinemaps.surveyofindia.gov.in. So we will download and then we will break for tea, and then once we come back we will upload our asset and then calculate the average elevation for any. So for you will require one login. You have to register, and then only then using your mobile number you have to register, and OTP will come, and then you can download freely available resources. In this Survey of India portal, You will also have paid resources like topo maps, DEM, etc. There are paid resources, all paid resources also, but shape files of states, district, talukas, villages, even village shape files are available. Village shape files are freely available for downloading from this portal. So, but to access, you have to have login. So I have my login, which is through. Let me download. It is very slow here. Otherwise, we could have also used vector data, which is available in the Google data catalog, but I don't want to do that because I want you to learn how to upload any shapefile and to make create any asset for usage. So you can see, just pay attention on the screen how to download once you get your login. So once you log in, you will get an OTP on your mobile. It is just like simple online shopping portal where you will add to your cart what all you require, and then you make the payment. Here you need not make any payment because we will be selecting only free resources. Oh, it is asking me to set again password. One minute, just a minute. Okay. Yeah, here if you see, there is one option of administrative boundary database. You can see many of these products are priced. You can select this administrative boundary database. There is also village boundary database where you can download shape files of villages. So in the administrative boundary database, actually it is taking time to load. Let me go there. Yeah, here you can see entire country up to taluka level with headquarters, entire country up to district level with headquarters. It is priced at 0. So I will click this, click to buy. Uh, Actually, net speed is okay. We will break for tea. Once you come back, we will continue. यहीं पे ले गवर्नमेंट नहीं प्राइवेट
आप सर चाय मंगाए यहाँ पे
Yeah.
8 o'clock
हाँ ठीक है
थोड़ा जल्दी होता है फिर भी ठीक ही है
ठीक है
मतलब
हाँ चले जाऊंगा
चले जाएगा
What is the name of this district? Kamrup Metro? Huh? This is rural, but Guwahati is a metro. There are only two districts, right? Here. In the WhatsApp group, I have circulated one district shapefile, zip format, Kamrup rural. Okay, you please download it. Download it onto your system. Everyone is back. So please download that district shapefile. Only zip in the zip format only we will require. In the WhatsApp group, I have shared it. Please download onto your systems. Each and every system. Earlier. So shall we start? बाकी लोग का है Is it still being recorded? This one? So anyway, हाँ? ये बीच में स्टॉप हुआ क्या? अच्छा चल रहा है
स्टॉप सर नहीं होता
Okay, okay. So anyway, everyone has zip file with them. Oh, actually, from the same source where I have downloaded the district shapefile of the entire country, and I have identified one, selected one feature, Kamrup rural district, and then I have saved it onto my system and zipped it. So whatever shapefile that you have to place all the subfiles with different extensions .shp, .shx, .dbf, .prj. All those files should be zipped. The folder should be zipped and create a zip file. That is the first step. Once you have the zip file, how to upload your asset. Now go to your assets. Okay. Now you are working under some project. Like I am working under E-Chaitanya case. In your case, in the morning we have registered a cloud project. Under that cloud asset, okay. Under that cloud asset, you select that this one. Select your cloud project. Under assets, select your cloud project. In your case, there will be only one project, so there will not be any issue. Then click on new. Click on new, and then select this option of shape files. So you can see either you can upload different files or you can upload zip file in one go. It is much more conducive or much more easier to upload zip file. So you click on this zip file, then you select wherever you have downloaded and saved the district shapefile. You select that. In my case, it is here Kamrup rural. Then zip file, open. So you can see a new asset ID is being created. Just like every image file has an ID which is unique. Every image, every data set, image or image collection, feature or feature collection has an unique ID. Similarly, whatever asset that you are creating, that will also have some unique ID. It will start with project slash project name slash asset slash the name of the asset that you are uploading, and then you click on upload. Simply click on upload. Now you can, once you click on upload, you can see that in the right hand side panel tasks, something is activated. You need not do anything, it will do on its own. right? In the right hand side under task, it is activated and you can see that wheel is running. That means it is getting uploaded. So your shape file in the zip format is being uploaded in your assets. Now it will take some 1 or 2 minutes. You can give time for that. And meanwhile, let us see some other scripts. Let this work. We will come back to the script number 28, average elevation calculation. We will do that for this particular district of rural Kamrup district. So once it is done, once the ingestion is done, you will find a tick mark here. Now you can see it is still revolving. That means it is still ingesting. It will take some time. Now let us move to back to the scripts. I will go to the script number uh, 29, rainfall statistics. From now on, we do, because we don't have much time, we will just run and see the results. And I will tell you where to make changes. Like once you have this shapefile ready, we will do the same analysis for all these things for Kamrup rural district also. So for script number 29, it is calculating rainfall statistics for your area of interest. Again, your area of interest in this current script is Pune district shapefile, and we are making use of one dataset chirps. You can search for this dataset here, CHIRPS, which is a Climate Hazard Center infrared precipitation with station data, the full form of CHIRPS, which is a long time series of daily rainfall data, which is at a resolution of 0.05 degree. What is this 0.05 degree? At the equator, distance between two longitudes, 1 degree longitude is approximately equivalent to 110 kilometers. So 1 degree, please pay attention, 1 degree is equivalent to 60 minutes, 60 into 60 seconds. So 1 arc second is how much? No, that I think arc second, we need not go into arc second calculation. You can see 1 degree is 110 kilometers. 0.05 degree is how many kilometers? 0.05 into 110, approximately 5.5 kilometers or 5500 meters. So this cell size in CHIRPS data set is about 5.5. You can even check that in the band. If you see, there is also again one band here, only one precipitation band, just like elevation in SRTM. Here also every pixel will have precipitation value, and you can see the resolution is 5566, that is 5.566 kilometers each pixel size. This is the description. The data is available since 1981 January 1st. Every day you will get the daily rainfall in a pixel size of 5.5, and it is generated data set, and it is also uh, validated with some ground station data also. So it is generated by one university. The dataset provider, if you can see here, US UCSB CHG, UCSB CHG. It will take you to the dataset page. That is I think it is university, which is US based academic institution, which generates this data set. Okay, so anyway, I am not getting into the data set, and you can also click on this C example to open a new window on code editor, and you can check the example. You can run that example. Now for the time being, I am just running the script which is already there with you. It is basically, it is calculating it is fetching the data. Here you have see Now if I want to import my data, I have to simply click on this import button either here. So if I do this, it will create a import button, and then I have renamed it as chirps. Now it is an image collection because every day there is a new image. There is a stack of images, image collection. Now I have renamed it as chirps, and my region of interest is again my Pune district. Now we will do it for Kamrup also. Now in this line number 8, what I am doing? I am applying a function filter date. And if I check this filter date function, if you go into docs and check this filter date, which is being applied, this filter date is being applied on which data set? Chirps, which is a image collection. So I have to see the function ee.imageCollection.filter date. So you check the ee.imageCollection.filter date. So this is a function which takes start date and end date, and it will filter images from that start date to end date. End date is not inclusive. So if you are filtering for 1 year, you have to start from 1st January so and so year, and the last date should be not 31st December but 1st January of next year. Last date is not inclusive. Understood? So here I am filtering the data for the year 2023. Then what happens? I am filtering from 2023 January 1st to January 1st 2024. Now what will be this chirps filtered? It is a subset of the chirps image collection having 365 images or 366 images depending upon it is a leap year or not. 2023 it is not, it cannot be a leap year, so there will be 365 images. How to check that? Let me comment this. Please pay attention, don't do anything, you will run the whole script afterwards. Now if I want to check what this variable is, what I need to do, what is the simple way? I will print it. I will print this variable to check how many elements are there in this image collection, how many images are there in this image collection. Then I will click run. So only this line will be executed. You can see on the console, it is an image collection having 365, and how they are stored? They are stored as a list of images. A list with each element in the list being an image. Indexing starting from 0, 1st January 2023 and so on to 31st December 2023. The last one is 364 because we are starting from 0, 31st December 2023. So there are 365 images. So in that way, what you do, you can check your any data set by printing onto the console. Now I don't want this line, so I can remove this. Now what this remaining part of the function does, this one, now this line is calculating what? It is summing up the precipitation for the entire year. So for every pixel, it is getting the rainfall information, rainfall data from each of these 365 images, and then summing it up, and then it is creating one single image having each pixel having total annual rainfall. This function is dot sum. We are applying dot sum function on this collection. Next, we are visualizing this total rainfall by adding onto the layer. No, I have commented this out, that is not required. Then I am centering my map to, actually I have done this for National Water Academy, I think. So I am centering it for coordinates of National Water Academy at some zoom level at Pune. Then I am clipping the total rainfall image to my region of interest using this function clip, so that I will only get it for Pune, right? And then I am calculating the average annual rainfall for Pune, for that whole district. That means what we are doing? We are calculating the average annual rainfall for Pune district here for 2023, right? So here again, reducer is E dot mean, geometry is ROI, scale is 5566, that is the resolution of chirps. And then I am printing the result. Okay, if I run this, you can see precipitation, average precipitation for the year 2023 or Pune district is 884.95 millimeters as per the CHIRPS data set, right? Now, if you want to do this for any other district or any other region of interest, you have to simply change the area of interest or region of interest. Now, let us check whether our ingestion is done. Yes, it is done. You can check in your case also. You must have you must have completed ingestion of your asset. You can refresh to see. So I am refreshing. You can see I have a new asset, private asset, Kamrup Rural. Now this is your private asset. What I can, in case of Pune, what I have done is I have uploaded it, and you are able to do access that also. How you are able to access it? Because I have gone to this share button, and then I have given this option tick, anyone can read. That is why you are able to make use of it. You can do it for even any other district. But now that you have all uploaded your own private asset, let us make use of it. How to make use of it? Click on this, go to assets, click on your district, and you will again find this import button. Click on import button. You can see that it has a unique table ID here. Table or vector are synonymous. So I will click on import. Then a new import section will be generated in my, on the top of my script, and the variable by default will be table. What I will do? I will change it to ROI. But I cannot have two ROIs. What I can do is I can delete this, or I can change this to ROI1 or ROI2, something like that. But what I will do, I will let me do that. I will delete, I will not delete the original one. I will rename this my new area of interest, which is ROI1. Now in the script, wherever we have ROI, I have to change it to ROI1. There is only one location. Here I will change it to ROI1, right? Now if I run this, but also I have to I will do this afterwards. First let me get the value. So if I run this, it is 1557.88 millimeters. Kamrup rural district average annual rainfall in the year 2023. Now you can do this for every year from 1981 onwards, and you can make a chart. You can prepare a chart. So next script is that. So I will go back to the average elevation calculation, script number 28. I will not save any changes. Here again I will import to calculate average elevation of Kamrup. Import, and I will change it to ROI1, and again here I will change it to ROI1. What do you think the average elevation would be? Does anyone know the value? Let me run this. So average elevation is 108.58. I think it is reasonably correct. It is most of the portion is it is partly hilly, partly plain, right? So this is how you make changes in the script by and do the analysis for any area of interest. Now let us come to script number. I will not save any changes. Let us now come to script number 30, where you want to plot the you want to create a chart of average annual rainfall over Pune district from 1981 to 2024 or 23. Right? Now forget about everything. So you can see from the beginning year, start year, and you can see your ROI, your chips. These are the places where you have to change, make changes. This is the you can even see the comments. Create a chart of annual rainfall averaged over Pune district using ui.chart.image.series by. Now you can select this function and look in the docs what this function does. So please check. We don't have time. We cannot explain each and every line. But ultimately, if I run this, you will get a chart. Just like we have done it for 1 year, we will do the calculation for how many years? 81 to 2023. How much time do you think it will take? It will not take proportionately the same into 40 years. It will not take that much time, right? Because of parallel computing ability. Now, if I run this, you can see it is generating the chart. How much time it took? Few seconds. This is otherwise not possible to do in such a short period of time. So you can see the values are from 1981. You can check the years where there was very high rainfall, surplus rainfall. Year 2020. You can even change this x-axis, y-axis, etc. You can customize all these charts. Okay. So drought years are also, you can notice 2002 was all over the country there was drought. It was the lowest rainfall is 623. This is for Pune, and highest rainfall was 1400 overall district average. Now if I want to plot uh, if I want to plot the same thing, if I want to plot the same thing for say Kamrup, how do I do that? You have to change the ROI. Now let us see. I accidentally crossed the window. Just a minute. I think it will still. No, it doesn't remember because it was incognito. So I think you are getting now. You know how you can make use of these scripts for doing analysis for any part, for any region of interest. So please do it for your district and see the chart. Please do the analysis, rainfall statistics over a period of 1981 to, you can change even include the year 2024. Right? Can you do that? Annual rainfall chart for any district. So let us move forward. Or let me run the script for Kamrup once. I will import. I will rename it as ROI2, and I will change ROI2. Sorry. So see, it is generating the chart for Kamrup district. As you can see, the scale, the y-axis, the scale has changed. In Pune, it was highest value was about 1400. Here, the highest value is more than 2800 mm. But there is abnormally low rainfall. I don't know. Is it true? Means the value was only 1450 mm in the year 2021. You can check, cross verify it with the actual data, and the highest value was 2800 in the year 1988. And one more thing is, you can download the CSV also. If you want to have an Excel file, here you see this option. You can download the PNG. That is, you can download the image. You can also download the CSV file. If I click on this download CSV file and save it, so you will get this Excel file of average annual rainfall for 41 years, or how many years? I think it is 43 years. So these you can get the CSV file also. So let us move to the next script, which is script number 31, export image to drive. Okay, suppose you want to uh, export any image, whether it is final rainfall map or slope map or even SRTM, a digital elevation model, for any area of interest, and you want to download it and do some analysis, uh, which may not be which, for which Google Earth Engine may not be suitable. Like many things, Google Earth Engine will not be suitable. Number one, it is not, you cannot do what, you cannot do hydro processing, and you cannot do basin delineation using Google Earth Engine. It is not possible, because it requires a different kind of algorithm, or what you say, it is not meant for that. This is meant for mapping and analyzing, visualizing things over a period of time, and parallel processing, which requires parallel processing, etc. Whereas if you want to do the basin delineation, you have to make use of the algorithms like D8 algorithm, etc., which are there in the GIS software. So suppose you want to clip a portion of the SRTM DEM for an area of interest and download it to your Google Drive, and then you open it in the GIS software and do the basic delineation. For that, you can make use of this script, which is here. I have defined my area of interest, which is a polygon, which is, I think it is a rectangle, which I have created. I have created one rectangle here for some area of interest. You can do this even for your area of interest. Say, go to zoom to any area of interest and use these geometry tools to create a polygon or rectangle. Okay, and you rename it as ROI, and then you run this script. Here I am also giving color palette for displaying of my SRTM layer, and then I am exporting. This is the function export.image.to drive. And if you check this function export.image.to drive, because of the paucity of time I am not taking it up, but it will have many other parameters. It is not like you can export the whole SRTM DEM for a large area. It will not allow. It will give you an error, because you see there are so many parameters. There are so many parameters. One parameter is max pixels, the maximum number of pixels that it can export, which is by default value is, I think, 10 power 8 10 power 8 pixels. Suppose if you are choosing a very big area, like if you are choosing a small district, I think it will not be an issue. Not even small district, many a times even at district level it will have more number of pixels. So what you can do is you have to change this default parameter whenever you are doing the export for a large area. You have to change this max pixels value. Default value is defined as 10 power 8. You have to increase, say 10 power 12 or 10 power 13 or 10 power 14, depending upon how big is your area. Then you can export. But there is a problem here. If your drive itself, Google Drive itself is full, then you won't be able to export big area, like big files. Then also it will create an issue. So basically this is just to show you that you can export your final results. Like when we have created slope image in a previous example, and you want to export to as a geotiff file, you can do that. For small region, this should be used sparingly for small areas. And there are other parameters, like what you call max image name. Just a minute. Yeah, here I think max pixels, by changing there is there is one parameter called best effort in some other functions. Um Here it is, if the number of pixels are exceeding, you can increase it, and then you can export. So you can run this. If I run this again, my tasks will be activated. You see, my task will be activated whenever I want to export. Unlike in the case of ingesting a private asset, here you have to run this task. Unless you run this, it won't be exported to your Google Drive. So after clicking on run, go to task button and run this. Then it will be exported to your Google Drive, and you can specify. There are many other parameters. Where do you want that to be exported? If you want to be exported to a specific folder, you can name the folder. Then it will create a specific folder in your Google Drive. So many things are optional here, so I haven't included them. All the parameters values are not being passed. Are you following up? बताइए. क्या हुआ? हमने तो बहुत, we have just shallow, very shallow, we have covered only superficially, we have covered. Otherwise Google Earth Engine is a very, it is vast. We are just doing basic operations like calculation of average elevation, average rainfall, etc. Okay, so let us run the scripts then, and then I will leave it to you. You have to do on your own. Okay, next script, generation of histogram. Suppose you want to generate histogram for your area of interest, means how many pixels are within the range of fixed class intervals, different class intervals of elevation, how many pixels are there. Okay, so if I run this, please click on run and see the result. You also please do it on your system. Click on the script 32 and run it. And it's check in the console, you will get this histogram, which is the histogram of elevation of Pune district, where you can see on y-axis frequency is the number of pixels which are falling within this range of 400 to 600 meters, 600 to 800 meters. So most of the area in Pune district is in the range of 600 to 800 meters, but many pixels are in the range of even 400 to 600. Very few pixels are above 1000 meters elevation. You can do this for any other area of interest. Okay. Now let us move forward. Masking an image. Now you run this and check what it is doing. I think it is masking areas which are above 1000 meters. So you see there are three layers here. Please click on run. Script number 33, please click on run. What it is doing? It has generated three layers. You can check in the layers. First one is the usual Pune elevation DEM with a color scheme. And then second one is a mask, 1000-meter mask. That means it is a Boolean image. Wherever the values are greater than 1000, it is white, and wherever the values are greater than less than 1000, it is black. And then I am marking only those areas which are 1000 mm only. So you can check which are in red. These are the areas or pixels which are greater than 1000 mm, 1000 not mm, sorry, 1000 meter elevation. You can do this. You can change the value 1000. You can change the value Pune and you can do this for you can create different zones of elevation. You can display say 500 to 750 in one color, 750 to 1000 in another color, something like that, right? Yeah, elevation zones, I think that this one will do that. So in this script I will just run and check the result. Yeah, here I haven't you can even create a legend with the description. So you can see in the elevation zones there are different color codes for different zones. Blue portion, it is less than I think it is less than 250 meters, it is blue. Between 250 to 500 meters, it is green. So you can see this portion, there are areas below 250, below 500, 500 to 700, 50, 750 to 1000, 1000 to 1250. You can similarly do the same thing for any other area. Okay. Now, calculation of, now the next folder, now we have, till now we have worked only with single band images. That means either with SRTM or with rainfall chips data. Now multi-band images are normal multispectral imagery, Sentinel to our Landsat. So we in the morning we made a reference to NDVI, NDWI, right? So here you can just click on script number 35, which is basically it is creating a composite. It is creating a median image. Now why this median image? Because suppose you want to create a relatively cloud free image. If you take all images from a particular year, there will be some days where pixels are occupied by cloud, and some days when they will be occupied by cloud shadows or something. So if you are taking median value, so I hope you know the difference between mean, median and mode. Median value means it is lying centrally, or 50 percentile value. It will be relatively cloud free. Understood? Every pixel will have reflectance value from different dates. For every pixel, if you are taking median value, it will be more chance of it being not covered by clouds. For every pixel, if you take maximum value, maximum reflectance value, then what we have, definitely it will be cloud. Cloud means what? High reflection. So if I do the median, you see this is the max image, your max image on the top. Nothing is visible. So for a whole year, for every pixel, you are selecting the imagery from a particular date when that pixel was having highest reflection. So every pixel in this composite image will be from a different date. Got it? Max image. Then if I see the median image, it is relatively cloud free. Now let me come to the script number 37, computing NDVI. How do you filter your image collection, whether it is Sentinel-2 or Landsat 8 or 9, for one particular year, for one region, and then sort it by cloud cover. In case of Sentinel-2, there is one property, cloudy pixel percentage. In case of Landsat, there is one property, cloud cover. And you sort and then you choose the least cloud cover image by selecting the first image. Once you select like Landsat, after every 16 days there will be one image, Landsat. So for how many images will be there in 365 days? 365 by divided by 16. Okay. So some images may be having high cloud cover, especially during monsoon, and some images will be having low cloud cover. Now when we are sorting by this property of cloud cover, it will arrange all these limited number of images pertaining to one particular year or one particular area with least cloud cover image be the first image and highest cloud cover image the last image. So you can, if you are selecting the first image, that is the least cloud cover image, and we are picking that least cloud cover image for calculation of NDVI. NDVI, we know what is the formula. NIR, you take two bands, NIR and red band, and you do the normalized difference. In Google Earth Engine, there is an inbuilt function, normalized difference, which will take two bands for generation of normalized difference image. So this script is about that, selecting a least cloud cover image, and then you calculate the normalized difference, and then plot the NDVI with a color scheme. Now you can see if I run this, the high green, thick green color means high NDVI value, medium low NDVI value, yellow may be bare soil, white, what do you think is white? Huh? What are these white? They are water. Because NDVI for water, what did I say in the morning? just below zero value. For water, NDVI is just, it will be invariably, it will be just around 0, less than, slightly less than 0. You can even check the values from inspector. If you click inside any water body, these are big reservoirs. You will find the value minus 0.25. And if I click on any thick vegetated area, it is 0.62. 0.6 or 0.7 is considered to be very high NDVI value. Maybe there may be thick vegetation. It is, I can even check this, like, let me display the satellite imagery. You see, these are thick wooded area, thick forested areas. There is also bare soil, bare rocky outcrops. But if you check the NDVI value, these are like permanent vegetated forested areas. So they are having very high NDVI value of about 0.6 and above. Okay. So if you want to adopt this script and do it for your area of interest, what you need to do? You change the ROI. Maybe you have a look better. Yes, I think it ROI, but in this case ROI is not my Pune district. I have selected single point as my ROI. So whichever Landsat imagery is intersecting with this single point, for 1 year you are selecting it, and then from that 1 year you are picking the least cloudy image. You can do it for any other regions by simply changing the latitude and longitude, or by creating a new marker. Add a marker. You can go to any particular point, say, let me do that. Which region you want to this to be done? Shall we do it for Guwahati? You come to, so let me click here somewhere near Guwahati. I will click a point. Let me delete my old ROI. Let me add a new ROI, and let me rename it as ROI, and let me run this. As simple as that. Now let us see. It is hardly taking few seconds of time. So one scene of Landsat occupies this much of area. You can clearly see water body, water bodies. Here also there is one water body, Umiam Reservoir, and thickly forested areas, northern slope, and then here also. And then these are densely populated regions where we have these areas, we don't have much greenery, right? Is it clear? So let us run one or two more scripts, and then we will close for the day. It is too much to cover in one day. So instead of NDVI, we can make use of NDWI. NDWI is green minus NIR divided by green plus NIR. And wherever NDWI is greater than 0, it indicates water. Provided it is not, there is no cloud. We only take cloud free images. Otherwise, it will interfere. MNDWI is a better indicator, which is a better index for mapping of water bodies. So you can see water bodies extraction using Sentinel as well as Landsat 8 imagery. You can run the scripts and see for whole district you can easily map water bodies in no time. And you can zoom in to see. First you are creating a cloud free image composite by taking median, and then using NDWI and NDVI you are creating a threshold. Now here you have it is a bit subjective because you have to decide the threshold value above below which value of NDVI you will consider it is water. I am saying NDVI will be very low for water, just below zero. So below which particular threshold it will be water. That decision will has to be made by you depending upon that particular scene. You can automate it also using some algorithm known as Otsu thresholding, which is statistical method. Similarly, NDWI is another index above which value of NDWI above 0 you will consider the threshold. So you can do this same thing for your own area of interest. That is about water body mapping. This one 52, script number 52, it actually does land use land cover mapping of Pune district. It is semi supervised land use land cover mapping. Here I have defined particular points from urban bare soil, water and vegetation classes by looking in the background of high resolution imagery, and then I am using this as a training data for generation of the LULC map for the whole area. Now simply click run and see. Now the land use land cover map for the year 2023 is being generated. It is taking some time. So you can see there are only 4 classes here. Water is very easy. Water is very easy to map because of its spectral signature is very easy to identify. The Pune city, this is built up area is in red color. There will be some confusion between built up area and bare soil because they have similar spectral signature. Otherwise vegetation and water are pretty easy to map. So you see this is at a resolution of 10 by 10 meter because I have taken Sentinel-2 and it is reasonably good. You can zoom in to see how well it has come. In fact, you can have the measures of accuracy assessment etc. also it is possible. Now you can see within the city it has clearly demarcated areas which are built up, which are bare soil, which are water bodies, even the river etc. they are clearly marked, right? Final script I will run. This is about mapping groundwater depletion. You may have heard about excessive groundwater pumping in northwestern India, in Punjab and Haryana. We have a data set known as GRACE. Earlier it was GRACE mission. Now it is GRACE follow-up mission. Unlike remote sensing of electromagnetic spectrum, it is sensing of gravitational anomaly. So there are twin satellites which are revolving the earth. If there is any abnormal change in the gravity, then it will capture there are twin satellites they will capture any gravity anomaly by even a minute difference of the I think if there is a greater anomaly the distance between these satellites, I don't know the actual mechanism, but there will be some variation and that can be you can get a trend of change in the terrestrial water storage. Terrestrial water storage includes not just the surface water body and snow, but also the groundwater. From year to year, generally there will not be much change in the surface water storage, because every water cycle, all the water bodies, they get replenished. The same thing happens with even snow or snow cover. But generally, if there is overdrawal of groundwater, which has been happening, and if the water, if the drawal is much more than the recharging that is taking place every year, then there will be a net loss of groundwater. That is, loss of terrestrial water storage is decreasing, and that can be captured. The only limitation here is the size of the pixel is quite big. I think it is about, you can check, it is about 50 kilo, more than 50 kilometers. So if you run this, you will get a chart. It doesn't give you absolute value, but for the whole two states, because it is very coarse, for the whole two states, you can get a trend. For Punjab and Haryana, you can get a trend, general trend of decrease in the terrestrial water storage or groundwater storage anomaly in these two states. There is a fall because of the excessive drawal of the groundwater or excessive pumping of groundwater. That this was featured in many research paper also. I think someone has brought this to light, and all of it was in news for a long period of time. So I end the session here. I think, I know it is too much for you to grasp so many things on one single day. So, but I hope you will appreciate this platform, how useful it can be to run time series analysis or to map anything over a long period of time. It will be very quite useful. So you please make use of the resources. The scripts itself, they contain lot of material in written in the form of comments. You please make use of it. I will also share few resources on QGIS, uh, including basin delineation, etc., which are from a course which we ran at National Water Academy. I will be sharing in the WhatsApp group, and also this will be along with the scripts. You practice it. If you have any queries, you can always contact me. Okay, then we can conclude it today. Thank you. Is there anyone? Huh? Stop streaming. There are two options.